Let's take a look at a foundation settlement question. We'll be using the following steps to solve this problem. 1. Understand the question. 2. Gather relevant formulas and constants. 3. Set up the equation. And 4. Solve the problem. Now let's explore the problem we'll be solving in this scenario. The problem states the following. A 30-foot thick clay layer is bounded by sand on top and gravel on the bottom. The coefficient of consolidation of the clay layer is 0.40 square feet per day. Our task is to determine which of the following options is most nearly the amount of days required for 90% of the total settlement to occur. Let's start this solution just like we do each time and list all the given information. The coefficient of consolidation is 0.40 square feet per day. The thickness of the clay layer is 30 feet and the degree of consolidation is 90%. Next, you'll need to navigate the NCEES handbook to find the relevant equations. Searching for the term time rate of settlement will direct you to section 3.2.3 of the NCEES. Here, you'll find the equations needed to solve for the time of settlement. Here is the equation as given by the NCEES. The problem statement provides the coefficient of consolidation C sub V. Next, we need to determine the longest distance to the drainage boundary, H sub D. In this case, the drainage height equals half the thickness of the clay layer, since it is bounded by sand on top and gravel on the bottom. This is known as two-way drainage, since it is bounded by two pervious layers. This gives us a drainage height of 15 feet. Next, we need to determine the time factor, T sub V. This factor is determined from the table provided in section 3.2.3 of the handbook. The time factor equating to a degree of consolidation of 90% is 0.848. Now we have all the variables required to solve for the total time. We plug the variables into our equation and solve for t. We find that the time required for 90% settlement is 477 days. In conclusion, the time required for 90% of total settlement to occur is most nearly 480 days. The potentially tricky part with this question is determining the drainage height. By understanding one- and two-way drainage concepts, you'll drastically reduce your potential for errors. The rest of the question is just plug and chug.